What's up everybody, my name is Synapse and we're here doing a video on some text to binary, binary to text using decimal. So basically numbers. The binary we're going to be changing and converting is the binary here that you can see. It's this long number that has a bit of effects on it. I wanted it to look cool, okay? Don't worry. Okay, so let's get rid of this. Let's make a workspace for ourselves. We take the binary code. What we do with it is, I'm going to explain this the way I learned it. So there is 3 letters. Okay. Now if we count how many numbers there are, it's 24. So we take 24, divide it by 3, and if it comes out with a proper number, then we know how many numbers one letter or one symbol has. So let's do it. We take it and we go add some dots. Okay. Next thing we're going to do, we're going to divide it by 20. Well, okay, so there's 24 divided by 3, which equals 8 digits. Okay. So we know that each letter or symbol is 8 digits. This is how I learned it, by the way. Okay, so let's separate the numbers. Each one of these sections of numbers equals a letter. Now it's a 3-word letter, just to get it into your mind that it's pretty damn easy. By the way, spaces also come in this form, and you have to put them in the right order. So like if you want a space in between these, you put it here. In between these two, you put it here. But when you put the numbers together, don't do any spaces. Okay, nice. Right, let's go to the next part. How do we work out this? Let's find out. Okay guys, so let me just take away all this stuff. Actually, I'm going to get rid of everything apart from this, just for later on. You'll see. Okay, so we have 3 numbers, right, 3 sections of numbers, which I'll get back to. Okay, I'll explain this first. So here we have a table. This table contains decimals, hexadecimals, octals, and they equal these chars. So like each one of these equals this in hexadecimal. Like you go 22, it equals 16 in hexadecimal, and it equals 0 to 6 in octal, which also equals syn, which is synchronous idle, which we're not going to be using. We don't need to do that stuff. So we're going to put on the screen only what we need, leaving this part here viewable, but it's fine. We don't need that stuff. So okay, boom. We're doing decimal to char, which is letters and numbers. Well, not fully numbers, but letters and yeah. Okay, we'll just say letters. Okay, so this table, I use it to convert my numbers, well, my letters to numbers, and then convert the numbers into decimal, into binary. Okay, so let's do it. Let's get an example here. We've got A. Okay, as you can see here, A equals 65. 65, okay? So now how do we get that to binary, you ask? Okay, so we go through this table. Now it's good to have one of these tables because I don't really do it in my head much, but I found it quite easy to do using a table. So you go from left to right, and we'll figure out how it works. So does 65 go into 128? No, it doesn't. So what we do, we put a 0 there. As you notice, guys, there's 8 columns, because it's 8 digits. 64, does 65 go into 64? It does, with remaining 1. Okay, so now we have 1 left, right? So 65, take away 1, take away 64 equals 1. So we know we've got 1 left, and it doesn't go into 32. Nope. Does it go into 16? Nope, there ain't enough. 8, nope. 4, nope. 2, nope. But it goes into 1. Okay? So that's how to convert to binary. But if you didn't catch that fully, I'm going to help you do it again. Wrong one. Okay. I'll just minimize that one. Okay. Next one. We'll do B for an example. By the way, it's the same as this, but these are just bigger numbers. Okay, so B. What we do, we look onto the chart for B. you see B, we go across and it equals 66. So, put it into the table. Does 66 go into 128? No, it doesn't. Does it go into 64? Yes, it does. With remaining 2. Does it go into 32? No, it does not. Does it go into 16? No, it doesn't, because we've only got 2. 8? Nope. 4? Nope. 2? Yep. And there's nothing left, so we just put a 0. Okay, so that's how to convert from text to binary. Now binary to text. So, I've got some other examples for this. I'm going to convert the word that I showed you earlier using these numbers. Let me just move them for you. Okay, that didn't work. Come down here. This one. Okay, first one. It's 0, 1, 0, 0, 0, 0, 0, 1. Okay. Okay. Let's focus on this one. So we enter the digits. Okay. So we've entered it into our table. Now, how do we convert it? You ask. What we're going to do? We're going to see and look for ones. Zeros are just placeholders. Okay. So 1. Which equals 64. So we have 1 times 64. We have 1 times 1, right? So basically 64 plus 1 equals 65. Now if we go into our table and we look for 65 down the list, we find it equals A. Okay? Next. We do the next. Okay. So we look at our table again. We go, okay, there's 1 here, there's 1 here. That's 64 and 4, which equals 68. We go into our table, we look at, and we find a D. So it's AD at this moment in time. Let's go to C. Okay, so 0, 1, 1, 1. Okay, so look at the ones. 64 plus 2 equals 66. Plus 1 equals 67. So we look at our list for 67 and it's C, which equals ADC. So that means this code, this binary code right here, equals ADC. Okay, guys, let me just add that for you so you guys can see. This one equals A, this one equals D, this one equals C. Okay, so how do we put spaces and stuff, if you want to know that? We just look in our list again, which I'll get rid of this stuff. Okay, so if we want to do a space, we look at 32, which is here. 32 equals a space. So we go through this list. This would be 0, 0, 1, and then all the remaining would be 0. So it'd be 0, 0, 1, 0, 0, 0, 0, 0, and that is how you do chars and text to decimal binary. Okay. So if you have any problems with this, or you want me to do a more thorough tutorial, please do tell me, and I can do that for you soon. I'm going to try and work out how to do hexadecimal. Try to work out the ways of the hexadecimal, and then I will make a video on it, and hopefully octal as well. But I've got to learn them first, which I'm going to take my knowledge from learning decimal into hexadecimal. Has a different type of table. By the way, we haven't used this table. That's just because we haven't needed to. We haven't done anything big. If we were to do my name, for instance, I'd put my name DAYLE, and then I put each binary number here, and after I would just slot them all together, and it would make the big ass binary code. But if you want more examples, please do ask. Hopefully it was good and it was easy to understand. But if you have any problems, you comment below and I will help you as soon as possible. Okay, make sure you do that. Thank you. Peace out, guys. Hope you enjoyed your day, and I hope you enjoyed this tutorial. Thanks, guys. Peace.